So I forgot to begin the last video with our Lego man of the unit, and this happens to be Saruman from Lord of the Rings. It's not exciting. He's got his nice white cape and his. Or is this Gandalf the White? Oh, I don't know. Okay, so we left off in the last video having found out the percent of time that our students spent in each of these 5 categories. So then we got this suggestion here that we've got studies out there saying that you should get about 6.5 hours of sleep per night on average. But if you want to improve your academic performance, you should get 8 hours of sleep on average. So we're asked here, what percentage of the hours in a week would be devoted to sleep if you get 6.5 hours per night, and what percent if you get 8 hours per night? Well, we should be a little bit careful here. So for the 6.5 hours, note, I'm going to call that 6.5 hours. We can look at this two ways. How many hours per night would we need to get? That would be 6.5 divided by 24 hours. So the per night calculation. Or we could do this as a calculation per total hours in a week done. So we know that the total hours in the week is 168. We would need to get 6.5 hours for 7 nights. Now, this calculation, I think we are going to skip, because if you recall how we got this 168 number, we did the 24 hours in one day times 7. So if you look at this fraction that we're creating, if we simplify it, divide out that 7, we're left with the 6.5. Now, we're gonna toss this into decimals, but notice what we're gonna get is a decimal version of the percent. So 6.5 divided by 24 gives us 0.2708 blah blah 3 on forever. So 0.27083 repeating. In terms of a percentage, if we round to the nearest percent, that means we want to round to this 7. And since the 0 after the 7 is less than 5, that means we're looking at 27% of your week should be spent sleeping if you get the 6.5 hours. Now, if you want to improve your sleep, we're going to do the 8 hours per night divided by 24. And I happen to know that 24 divided by 8 is 3, so this is 1/3, which as a decimal is 0.33333 repeating forever and ever and ever. And as a percentage, that's 33% if we round it to the nearest percent. So our question here then says, well, how is our student doing here in terms of sleep? So if we look at those percentages for sleep, they were at 32% of their week they were spent sleeping. So they're right within the recommended hours of sleep. They're doing pretty good. Okay, last thing we're going to do is we're going to then say, well, if we're going to create a pie graph of these data, we want to figure out how many degrees of that pie graph is a circle, where each of these categories take up. So first, a few things to mention. Degrees is an arbitrary measurement of a circle, and someone just decided that we should call a circle 360 degrees. This little symbol here is the degree symbol. And so if I were to draw a circle, and if I were to start here and walk all the way around or rotate all the way around the circle, I would have spun around a total of 360 degrees. So what happens is, if we want to take these categories and determine how many degrees in a circle will each of these categories take up, we take the percentages we found here and multiply the decimal versions of them times 360 degrees. So in other words, under class, where that was rounded to 9%, to find the number of degrees, we'd say 0.09 times 360 degrees is the number of degrees in the circle that section would take up. Likewise, 0.19 times 360 degrees, 0.32 times 360 degrees, 0.09 times 360 degrees, and finally 0.31 times 360 degrees. Doing these calculations will get the number of degrees in a circle that each of these categories would take up. So I'll do a couple of them. 0.09 times 360 gives us 32.4 degrees. 0.19 times 360 gives us 68.4 degrees. Oh boy, well, that did not work out. There's our 115. Did the 0.09, so we don't need to repeat it. 0.31 times 360, and we've got all the degrees in a circle, so it's 111.6 degrees. And one of the things you're going to find is you should say, oh, okay, I know that all of these represent the sectors of a circle, and if I were to add these all up, I should get 360 degrees, but if you do that, you're going to find you do not get 360 degrees. That's because we rounded these percentages from earlier. Okay, so if we were going to create this thing by hand, we would draw a circle and then do our best estimate. So I can chop the circle into 90-degree sectors. So half of the circle is 180, and then a quarter of the circle is 90 degrees. So I know this would be 90, this would be 180, this is 270, and when I finally get back to my starting point, I got 360 degrees. So let's see, if I wanted to try to put in the class, which is 32.4 degrees, I might try to say that this sector right here could represent the class, and that's roughly 32.4 degrees. And then from here, I could do another 68 degrees. I don't know, let's call this 68 degrees for the homework section. So we're going to actually do this in Excel because Excel is a much easier way to do this. So I've got here the percentages for each, and we don't actually need to include the degrees in here. We could if we wanted to. Let's do a quick check here to make sure our percentages add up to 100. So if I hit the equal button and then start typing the word sum, close the parentheses here, and then select the cells we want to add up and hit enter, we can see, oh, great, it rounded to exactly 100%. All right, if I want a pie chart, I would select the cells and then go to insert, and then under charts, I would go to this pie graph chart. And I want to go ahead and do a 2D, not a 3D. I think 3D pie charts are bad. And I don't really like this. It doesn't have a whole lot of information included in there. So I'm going to choose the one. We should title this, but we'll put it here. And this gives us the category as well as the percentage that each of them represents. And you can see that was getting close to what I was trying to draw. So this homework slice looks pretty close to the one I had. And the class slice, it's not too far off. But why do this by hand when you can let a computer do it for you?